Hi everybody. In this lecture I'm going to talk about monitoring Oracle GoldenGate. By the end of this lecture, you should be able to display the status of the processes, obtain reports on the extract and replicate lags, implement automatic heartbeat tables functionality, and finally view and understand the process reports and discard files. Many of the commands and tools that you will learn on this lecture report the status of a GoldenGate process. The status of a process could take one of the following values. Starting, and this value means the process has just started, but has not acquired the lock on the checkpoint file yet. Running. For a GoldenGate new learner, this value could be a little bit confusing because it means either the process is active and running fine as it should be, or it could mean the process is suspended. In a suspended state, the process is not active and no data can be processed, but the state of the current run is preserved, and the process can be continued by issuing the resume command in the GGSCI command prompt. Stopped value means the process has been stopped. This usually means that the process has normally been stopped. Appended value means that the process has been abnormally terminated. This could happen as a result of a network failure or hardware issue or an external condition that forces the process to terminate. Usually, this is a sign that a troubleshooting is needed. More about the troubleshooting will be discussed in a later lecture. Following are the GGSCI commands that you use to obtain information about the status of the GoldenGate processes. InfoAll command gives you a short output of all the processes configured in the GoldenGate and their statuses. Usually I use it to know the status of each process in GoldenGate in one go. Info Manager or InfoMGR provides the status of the manager process and the port number it uses. Info Extract or Info Replicate provides basic information about the extract or replicate process, like its status, approximate lag, checkpoint information, and associated trail files. If you use the detail option, the output will provide further details about the information that it provides. Stats Extract or Replicate provides statistics about the operations processed. Status Extract, Replicate, or Manager reports the status of the given process. Lag Extract or Replicate reports the latency between the last record processed and the timestamp in the data source. Info Xtrail or RMT Trail provides information about the trail files like the name of the associated process, the position of the last data processed, and the maximum file size. Send command in general is used in GGSCI to communicate with a running process, to obtain a specific information or send some instructions to it. Send Manager, for example, retrieves the status of the active manager process. Send Extract or Replicate can be used to retrieve vast pieces of information such as memory pool, the lag, TCP statistics, long-running transactions, and recovery progress. Each report generates a new report and a discard file when it starts up. Reports and discard files are aged whenever a process starts. Old files are appended with a sequence number, for example, hr0.rpt hr1.rpt, hr3.rpt, and so on. By default, runtime statistics are written to the report once, at the end of each run. To send the current runtime statistics to the report on demand, use the send extract or send replicate command with the report option. Use the view report to view the process report or the discard file that is generated by the extract or replicate. View GGSEVT command displays for you the contents of the Oracle GoldenGate error log file. Be aware that the group name in all those commands accept wildcards. Wildcard characters are asterisk for multiple characters and question mark for a single character. Perhaps the most important statistics that you always should look at is the lag. If the lag is increasing constantly, usually it is a fair indication that something wrong is going on. For GGSCI command prompt, you can obtain two types of lag, the extract lag and the replicate lag. The extract lag is the difference between the time that a record was processed by extract and the timestamp of that record in the data source. The replicate time is the time between the last record was processed by the replicate and the timestamp of that record in the trail. The first example in the slide is showing you how to use the lag command to display the lag information of the extract process, which its name starts with E. The second example is a command that displays the lag information of replicate processes whose group names start with R. This table is a list of the parameters that you can use to control how the lag is reported in Oracle GoldenGate. The first two parameters are used to define the interval at which the lag would be measured, either in minutes or hours. The three parameters in the middle are used to define the lag information threshold. If the lag exceeds the value specified by those parameters, the lag will be reported in the error log file as informational message. The last three parameters are used to define the lag critical threshold. If the lag exceeds the value defined by those parameters, it would be saved in the error log file as a critical message. You can build your own program to monitor the GoldenGate error log file and report to you any critical message that appeared in the file. The commands that we have learned give us information about the extract lag and the replicate lag, but they don't report the end-to-end lag. One of the important information you would be interested in is knowing the lag between the source database and the target database. And that's what we mean by the end-to-end replication lag. Before the Oracle GoldenGate release 12.2, to know the end-to-end lag, you should create a table in the source database and create a job that frequently updates it with timestamp of the source database. And then on the target database, you make the calculation to measure the difference between the timestamp received from the source and the timestamp on the target database. This solution is called heartbeat table. As I said, before Oracle GoldenGate version 12.2, you have to do the whole solution yourself manually. Luckily, Oracle GoldenGate release 12.2 provides you out-of-the-box automatic heartbeat tables functionality. This solution can not only calculate the end-to-end replication lag, but also you can obtain more information to evaluate the health status of your GoldenGate configuration. When you create the automatic heartbeat functionality, GoldenGate will create 3 tables, 2 views, 2 procedures, and 2 scheduler jobs. This solution saves information about your GoldenGate configuration like source and target databases, all the GoldenGate processes included in the incoming and outgoing streams, and it keeps track of the timestamp of the systems included in your configuration. The information in the table will not be useful if the clock is different between the systems. You should ensure that the clock is set correctly and it is the same in all the systems included in your configuration. Implementing the solution is quite straightforward. First, make sure that you are using the self-describing trail files, and those are the default trail files created by Oracle GoldenGate Release 2.2. Then you need to log in to the database using the db login command in the ggsci command prompt. After that, you issue the command add heartbeat table. You can set the configuration of the functionality in the same command that you used to create it. As you can see in the example in the slide, you can control the frequency in which the heartbeat table is updated in seconds, the retention time after which the data would be deleted from the history table, and the purge frequency, which specifies how often the purge scheduler is run to delete table entries that are older than the retention time from the heartbeat history table. If you don't specify those configuration, the default value of the frequency is 60 seconds, retention time 30 days, and the purge frequency is 1 day. You repeat the same procedure in all the databases involved in your configuration. If the processes are already running, you need to restart them so that this functionality gets enabled. Once you execute the add heart table command, it will automatically create the components listed in the table in the slide. You would have heartbeat seed table, and this table gets updated automatically on the source database. The update operations will automatically be replicated and applied on the target database. The replicate will update the heartbeat table, and it will also add it to the heartbeat history table. You would also have the update HP tab procedure, which will automatically update the heartbeat seed table. The second procedure is purge HP tab, which is used to purge the heartbeat table contents. The solution also creates two jobs. The first one calls the update procedure, and the second one calls the purge procedure. You don't execute the procedures manually. The jobs will take care of executing them on frequent basis. In Oracle database, those jobs rely on the scheduler. You therefore need to make sure that the scheduler is enabled and the job queue processes parameter has enough value to allow the jobs to execute. You also have the view called lag history, which is simply based on the heartbeat history table. This is probably the only component that should be of your interest in this solution, because this is the component you will select from to obtain information about your configuration and the lag in your environment. As I said, to monitor the lag through the heartbeat tables, you simply select from the GG lag history view. You can also use the lag command. This command will actually get the lag information from the views to report the lag to you in the command prompt. But you need to be aware that you must first connect to the database before you issue this command, if you want the command to display the full lag information to you. We will have a look at this solution in the next practice lecture. GoldenGate provides some commands to manage the heartbeat functionality. This table is listing the commands that you can use to manage the heartbeat functionality. Report files generated by GoldenGate processes have information such as the ones listed in the slide: parameters in use, table and columns mapping, database information, runtime messages and errors, and runtime statistics. A report generated by a process is a text file and can be viewed by any editor. If you want to display the report file from the GGSCI command prompt, you can issue the command view report followed by the process group name. Beside the report files, every extract and replicate process generates a discard file, which has information about GoldenGate operations that failed. This includes the database error message, the sequence number of the data source or trail file, the relative byte address of the record in the data source or trail file, and some details of the discarded operation. To display the discard file, you use the same command shown in the previous slide, which is view report. A new discard or report file is created at the start of a new process run. If the active report or discard file reaches its maximum file size before the end of a run, the process abandons. To avoid this situation, use the discard rollover and report rollover parameters. With those parameters, you set aging schedules for the discard and report files respectively. These parameters set instructions for rolling over the files at regular intervals, in addition to when the process starts. With the examples shown in the slide, every Sunday at 2 a.m., a new discard file will be created, and the old discard files will be renamed. No process ever has more than 10 aged reports or discard files, and one active report or discard file. After the 10th aged file, the oldest is deleted when a new report is created. ggserr.log file is generated by GoldenGate in the root GoldenGate directory. This file has the information such as the following: errors that occurred by GoldenGate process, history of the GGSCI commands, the processes that started and stopped, and informational and warning messages. The good thing about this file is that the messages in it are ordered by time, which is very useful to have an image of the history of your GoldenGate operation. You can use any editor to view the GGSERR file, or use the command view ggsevt command in GGSCI command prompt. Oracle GoldenGate writes its errors at the operating system level to the event viewer on Windows or to the syslog on Linux. Oracle GoldenGate messaging to the system log in Linux is enabled by default. On Windows, Oracle GoldenGate messaging to the event viewer must be installed. To do that, you run the install program with the Add Events option. This program is stored in the Oracle GoldenGate root directory. To control the types of messages that Oracle GoldenGate sends to the operating system logs, use the syslog parameter. You can include all Oracle GoldenGate messages, suppress all Oracle GoldenGate messages, or apply a filter to include information, warning, or error messages, or any combination of those types. And that's it for this lecture. You will implement the concepts that you have learned in this lecture in the next practice lecture. Thanks for listening. See you in the next lecture.